There is perhaps no greater testament to the Soviet philosophy of brute force engineering than the Mikoyan-Gurevich MiG-27, a machine that famously carried a gun so powerful that firing it often threatened to destroy the aircraft itself. In the annals of aviation history, we often romanticize the sleek, high-flying interceptors or the rugged, survive-anything-close air support platforms. But the MiG-27 occupies a strange, terrifying middle ground. It was an aircraft born from a compromise designed around a weapon system of devastating capability and operated on the very edge of structural integrity. To understand this machine is to understand a specific moment in the Cold War when the desire for overwhelming firepower superseded aerodynamic elegance, and when the solution to putting more ordnance on target was not necessarily smarter avionics, but simply a bigger gun and a more complex airframe. It challenges the common assumption that aircraft evolution is always a linear path toward greater reliability and sophistication. Sometimes it is a violent detour into a cul-de-sac of raw, unrefined power. This was not a friendly aircraft. It did not forgive mistakes. It shook, it rattled, and when its primary weapon spoke, the entire airframe convulsed in a way that terrified even the men who flew it. The MiG-27 was not named the Flogger D by NATO for nothing. It was a blunt instrument intended to inflict massive trauma, and it cared little for the comfort of its operator. To truly grasp the significance of the MiG-27, one must first strip away the identity of its progenitor, the MiG-23. While they shared a genetic lineage, the transition from the high-altitude interceptor MiG-23 to the ground-pounding MiG-27 was far more radical than a simple change of designation suggests. The Soviets needed a dedicated tactical strike aircraft to replace the aging fleet of subsonic fighters, something that could keep pace with a tank column moving across the plains of Germany and deliver precision munition or unguided ordnance with equal lethality. The Su-17 was already in service, a rugged swing-wing modification of the ancient Su-7, but the VVS, the Louviers Air Force, wanted something more advanced, something with better visibility and heavier lifting capacity. They took the MiG-23, a Mach 2.35 interceptor, and fundamentally lobotomized it for low-altitude warfare. This was not a downgrade, but a specialized transmutation. The complex variable geometry ramps on the air intakes, designed to slow down supersonic air for the engine at stratospheric heights, were deleted. We saw them replaced with lighter, simpler fixed intakes. This seemingly minor change saved nearly 300 kilograms of structural weight, but capped the top speed at Mach 1.7. It was a deliberate trade-off, arguably one of the smartest decisions in the program, because a mud mover hauling 4 tons of bombs has no business flying at Mach 2. The design team at Mikoyan recognized that the battle would be fought in the thick, turbulent air below 3,000 feet, where transonic acceleration mattered far more than raw, straight-line speed. If deep dives into the strategic and technical decisions behind Cold War fighters interest you, subscribe. There are plenty more aircraft worth examining closely. The defining feature of the MiG-27 and the element that dictates much of its structural narrative is the GSE-630 cannon. Most aircraft are designed, and then a gun is fitted into the available space. In the case of the Flogger D, one gets the impression that the gun was placed on the hangar floor and the aircraft was built around it to serve as a flying carriage. The GSH-630 was a 6-barreled 30mm Gatling-style rotary cannon that makes the American A-10's GAU-8 Avenger look almost civilized by comparison. While the American gun is hydraulically driven and massive, the Soviet counterpart was gas-operated, lighter, and fired at a staggering rate of roughly 5,000 rounds per minute. But the raw numbers do not convey the violence of its operation. The recoil force generated by this weapon was approximately 5.5 tons. When a pilot squeezed the trigger, the aircraft did not just vibrate, it shuddered with a ferocity that threatened to tear components loose. There are documented accounts of the recoil shattering the landing lights mounted on the nose gear doors. The impulse was so severe that it could cause the navigation system to drift, the radio to fail, and in extreme cases, crack the fuel tanks protected by the armor plating. The instrument panel would blur, rendering gauges unreadable during the burst. It was a weapon that punished the user as much as the target, a brutal interplay of physics where the airframe was subjected to stress limits that the engineers had barely anticipated. This was not the precise surgical strike of modern warfare. This was a flying sledgehammer. The airframe itself had to be radically redesigned to accommodate this mission profile. The nose of the MiG-23, which housed a massive intercept radar, was removed. In its place, the engineers drafted a sharply sloping, tapered nose profile that earned the aircraft the nickname Utknos, or duck nose. This was not an aesthetic choice, but a frantic attempt to give the pilot visibility. In a ground attack role, seeing the target is everything. The interceptor heritage of the MiG-23 meant the pilot sat buried in the fuselage with poor over-the-nose visibility, acceptable for watching a radar screen, but suicidal for strafing a convoy. The steep slope of the MiG-27's nose improved the view of the ground significantly, although the cockpit remained cramped and rearward visibility was virtually non-existent due to the high spine and the canopy frame. The pilot was essentially strapped into an armored bathtub, titanium plates welded around the cockpit to protect him from ground fire, staring out through a commercially reinforced windscreen, trusting his speed and jamming pod to keep him alive. The landing gear, too, had to be beefed up. The spindly legs of the MiG-23 were notoriously fragile, but the MiG-27 was expected to operate from rough, improvised airfields closer to the front lines. The main gear struts were strengthened, and the tires were widened to lower the ground pressure, allowing the aircraft to taxi over packed dirt and grass without sinking. Under the skin, the avionics suit represented a significant leap forward for Soviet tactical aviation, specifically in the K variant. The MiG-27 came in several flavors, each with distinct capabilities. The base MiG-27 and the MiG-27D were competent but relied on simpler laser rangefinders. However, the MiG-27K was the true technological marvel of the family. It featured the Kyra television and laser sighting system, a complex optical window housed in the nose that looked like a glass balcony. This system allowed the pilot to lock onto a target visually and guide laser-guided missiles or bombs with a level of precision that was previously unknown in the VVS. The Kyra system was stabilized, meaning the pilot could maneuver the aircraft while the camera stayed fixed on the tank or bridge he was destroying. This capability put the MiG-27K on par with Western contemporaries like the Sepakat Jaguar or the F-4 Phantom equipped with pave tack pods. Yet this sophistication came at a price. The Kyra system was heavy, expensive, and temperamental. It required a level of maintenance that conscript ground crews struggled to provide in the field. The cooling requirements alone were a logistical headache. It was a classic Soviet paradox, a weapon system capable of incredible performance that was often grounded because a seal failed or a specialized technician was unavailable. The power plant driving this beast was the Tumansky R-29B300, a massive turbojet engine optimized for low-altitude power. Unlike the high-altitude interceptor engines, the R-29B300 was tuned to gulp the thick air at sea level and turn it into 11.5 tons of thrust with the afterburner lit. This gave the MiG-27 an exceptional thrust-to-weight ratio when clean, allowing it to accelerate away from trouble with startling speed. However, this engine was also a single point of failure. In the context of Cold War doctrine, where attrition rates were expected to be high, a single-engine strike aircraft was a calculated risk. If a shoulder-fired missile or an anti-aircraft shell found the engine, the aircraft was lost. There was no redundant power plant to limp home on, a luxury enjoyed by Su-25 pilots. The engine famously produced a thick trail of black smoke, making the aircraft visible from miles away, a trait it shared with the MiG-29. This smoke was not just a visual signature, it was a testament to the older combustion technology that prioritized durability and thrust over efficiency and stealth. The fuel consumption at low altitude was prodigious. Even with the variable sweep wings set to the most efficient 16-degree position, the loiter time was limited. The pilot was always watching the fuel gauge, calculating the seconds of afterburner he could afford before he had to turn back. The variable geometry wings themselves were a marvel of mechanical engineering, inherited from the MiG-23. They offered 3 sweep settings: 16 degrees for takeoff, landing, and loitering, 45 degrees for combat maneuvering, and 72 degrees for high-speed dashes. In theory, this gave the pilot the best of all worlds. He could extend the wings to generate lift for a short takeoff from a damaged runway, then sweep them back to reduce drag and penetrate the enemy air defense zone at Mach speed. In practice, however, the wing sweep mechanism was heavy and complex. It added maintenance hours and dead weight. Furthermore, changing the wing sweep altered the aircraft's center of gravity and aerodynamic center, requiring the pilot to constantly trim the aircraft or rely on the stability augmentation system to keep it flying straight. During a chaotic attack run, fiddling with a wing sweep lever was one more task for an already overloaded pilot. Most operational flying was done at the 45-degree setting, a compromise that offered decent maneuverability and speed without the extreme handling characteristic changes of the fully swept or fully extended positions. Operational reality for the MiG-27 was a mixture of fear and respect. Pilots who transitioned from the MiG-21 or Su-7 found the cockpit ergonomics to be a step up, yet still light years behind Western standards. The workload was immense. The PRNK-23 navigation and attack system was automated to a degree, ostensibly allowing the pilot to fly hands-off during the approach to the target area. But trust in the system was rarely absolute. The digital computer, the Orbita 2023K, was a primitive beast by modern standards, prone to overheating and logic errors if the power supply fluctuated, which it often did when the glorious GSE 630 cannon was fired. We must return to that gun because it defined the pilot's experience. Training manuals explicitly warned pilots against extended bursts. A short, 1-second burp of fire was all that was permitted. Anything longer than that risked structural deformation. There were stories of canopy jettison mechanisms being triggered by the vibration, leaving the pilot suddenly exposed to the slipstream at 800 kilometers per hour. There were incidents where the instrument panel vibration dampeners sheared off, leaving the gauges hanging by their wires. It takes a special kind of courage to fly an aircraft that tries to disassemble itself every time you use its main weapon. Despite these terrifying idiosyncrasies, the MiG-27 saw extensive service. It was the backbone of Soviet tactical aviation in East Germany, the tip of the spear that would have blended NATO armored columns had the Cold War turned hot. Interestingly, the Soviets chose not to deploy the MiG-27 extensively in Afghanistan. The hot and high conditions of the Afghan mountains were punishing for the R-29 engine, which struggled with compressor stalls in the thin air and high angles of attack required for maneuvering in valleys. The simpler, more rugged Su-17 and eventually the Su-25 Frogfoot bore the brunt of that conflict. The MiG-27 was a racehorse kept in the stable for the European Derby, considered too sophisticated and perhaps too vulnerable for the dirty counterinsurgency war in the Hindu Kush. This decision highlights the Soviet recognition of the aircraft's specific niche. It was a high-speed interdictor designed for the flat plains of Europe, not a mountain goat. The aircraft found a surprising second life, and arguably its most successful combat record with the Indian Air Force, where it was produced under license as the Bahadur or Valiant. India utilized the MiG-27M extensively, and it was during the Kargil War in 1999 that the aircraft truly proved its mettle in high-altitude combat, contradicting the Soviet hesitation in Afghanistan. Indian pilots flew sorties at altitudes of 18,000 feet and above, dropping precision-guided munitions on Pakistani bunkers perched on Himalayan peaks. The environment was brutal. The engine, gasping for air, had to be managed carefully. The heavy recoil of the gun was strictly managed, and often rockets and bombs were preferred. Yet, the Bahadur delivered. It was a stable platform for dive bombing, and its speed allowed it to ingress and egress before the enemy manpads could effectively track it. However, the conflict also exposed the platform's limitations. The high altitude meant that the engine performance was significantly degraded, and the takeoff runs from the bases in the plains with full warloads were harrowing. Knowing what we do now about the maintenance nightmare of the Kyra system and the self-destructive nature of the cannon, do you think the Soviets would have been better off pouring those resources into more Su-25s? Or was the speed of the MiG-27 a necessary capability? Share your thoughts on this strategic trade-off in the comments below. Comparatively, the MiG-27 sits in a fascinating position alongside the Sukhoi Su-17/22 fitter and the Anglo-French Seppicat Jaguar. The Su-17 was the robust, reliable truck. It had a better export success because it was simpler to maintain and could operate from worse airfields. The MiG-27 was the high-tech sniper, faster and with better avionics in the K variant, but demanding a logistic tail that few client states could support. The Jaguar is perhaps the closest Western analog, a dedicated low-level strike aircraft with similar navigation and attack capabilities. But where the Jaguar was refined, precise, and underpowered, the MiG-27 was overpowered, brutish, and rough. The Jaguar pilot would keenly monitor his energy state. The MiG-27 pilot simply pushed the throttle and let the 11 tons of thrust overcome the drag. The Jaguar's avionics were more user-friendly, the cockpit better laid out. The MiG-27's cockpit was a clutter of analog dials and switches scattered seemingly at random, a testament to the Soviet practice of adding new systems wherever there was a hole in the dashboard. The later variants, particularly the MiG-27M and D, attempted to address the cost and complexity of the K model. They replaced the fancy Kyra TV system with a simpler laser rangefinder and marked target seeker in the nose. This was a step back in absolute capability. They lost the ability to self-designate for certain guided weapons in the same way. But it was a massive leap forward in reliability and affordability. It allowed the aircraft to be produced in numbers that mattered. The duck-nose profile returned, and the aircraft settled into its role as a workhorse. It could carry an impressive array of ordnance: FAB 500 bombs, S-24 heavy rockets, KH-25 and KH-29 air-to-ground missiles, and even tactical nuclear weapons. The integration of these weapons was handled by the onboard computer, which calculated release points based on speed, dive angle, and wind drift. For the time, it was a sophisticated setup, allowing for blind bombing runs where the pilot released ordnance based on computer cues rather than visual sighting, vital for bad weather operations in the European theater. Yet we must address the Kyra system again because it represents the pinnacle of the design's ambition. Located in the nose, the optical window was prone to cracking from, you guessed it, the vibrations of the gun. The cooling system for the electronics used alcohol, a substance that was notoriously prone to being consumed by ground crews in the bleak winters of Russian air bases, leading to system failures. The laser designator required precise calibration, which would drift after a rough landing or a hard maneuver. It was a Ferrari engine put inside a tractor. The capability it offered was immense. A skilled pilot could guide a KH-29L missile through the window of a bunker from 5 kilometers away. But achieving that operational state required an alignment of stars: a working jet, a calibrated system, a sober ground crew, and a pilot who hadn't been shaken to a concussion by his own cannon. The legacy of the MiG-27 is a complicated one. Following the collapse of the Soviet Union, the Russian Air Force retired the fleet with surprising speed. By the early 1990s, most MiG-27's were parked in boneyards, while the older Su-7's and the slower Su-20 soldiered on. The reason was economic and pragmatic. The single-engine design was seen as a liability in the localized conflicts that defined the post-Soviet era, like Chechnya. The variable sweep wing was a maintenance hog, and simply put, the country couldn't afford to keep the complex avionics of the MiG-27 flying. It was a specialist weapon designed for World War III, and in the absence of that conflict, it was an expensive luxury. The Su-25 was better at close air support, safer with two engines, and cheaper to fly. The Su-24 Fencer carried a bigger payload further. The MiG-27 was squeezed out of the middle. Its retirement was a quiet end to a loud career. There were no tearful farewell tours in Russia, just a silent towing to the scrap heap. However, in India, the story was different to the very end. The Indian Air Force loved the Bahadur. They upgraded it, maintained it, and flew it until the airframes simply timed out. They appreciated its speed and stability as a gun platform. For them, the MiG-27 was a deterrent that kept neighbors awake at night. The thunder of its afterburner takeoff was the sound of security. But even there, the GSH-630 gun was treated with extreme caution. By the end of its service life, many pilots were advised to use the gun only in emergencies, relying instead on the external pods for strafing. The vibration fatigue on the airframes was cumulative. Utilizing the aircraft's primary weapon shortened the life of the aircraft itself. It is a poetic irony. The very feature that defined its existence was the one that had to be suppressed to ensure its survival. When we look back at the MiG-27 today, it stands as a monument to a specific engineering ethos. It was not about finesse, it was about efficacy. It was built to solve a problem: how to deliver 6 tons of ordnance at Mach 1.150 meters off the ground. It solved that problem, but the solution was violent and expensive. The pilots who flew it speak of it with a mixture of affection and horror. They describe the physical exertion of flying a mission, the sweat soaking their flight suits, the constant wrestling with the controls, and the adrenaline spike of the attack run. It was a pilot's airplane in the sense that it demanded everything from the pilot. It did not fly itself. It tried to kill you if you weren't paying attention, either by stalling a wing in a swept turn or by shaking apart when you pulled the trigger. The aircraft's visual profile is unforgettable. On the ground, it sits with a nose-down aggression, the heavy-duty landing gear splayed out, the wings swept back, looking like a crouching predator. In the air, with the wings fully swept, it looks like a dart, a purpose-built missile carrier. With wings forward and dirty with bombs, it looks ungainly, a pterodactyl struggling for lift. This duality is the essence of the variable geometry era, a time when aerodynamicists tried to cheat physics by changing the shape of the plane in mid-flight. It was a technological dead end, eventually replaced by relaxed stability and fly-by-wire computer controls that allowed fixed wings to do the job of swing wings without the weight penalty. The MiG-27 was the last of its breed in that regard, the final iteration of the flogger line that started with such promise and ended in the mud of the attack roll. One cannot discuss the technical aspects without mentioning the sheer durability of the basic structure. Despite the vibration issues, the core airframe was incredibly tough. It could absorb punishment from ground fire that would down a lighter jet. The titanium tub protected the pilot from 20mm rounds. The fuel tanks were self-sealing and filled with inert gas to prevent explosions. The hydraulic systems had backups, although the complexity of the plumbing was a nightmare for mechanics. There were instances of MiG-27's returning to base with half a wing blown off or the vertical stabilizer shredded. It was built like a tank, which is fitting for a tank buster. But unlike a tank, it had to fly, and the conflict between weight, protection, and lift, performance, was a constant battle that the Tumansky engine fought every takeoff. The export market for the MiG-27 was surprisingly limited compared to the MiG-23 or Su-22. Outside of the Soviet Union, only India, Sri Lanka, Cuba, and Kazakhstan operated the type in significant numbers. This was partly due to the Soviets protecting the advanced technology of the Kyra system, but also because client states preferred the simplicity of the Sukhoi products. The MiG-27 required a level of technical literacy to keep operational that many developing air forces lacked. Sri Lanka used them effectively against the Sea Tigers, using their speed to conduct surprise attacks on insurgent boats. In that theater, the MiG-27 was a spaceship fighting canoes, an overwhelming mismatch of technology. Yet maintenance was always the Achilles heel, and readiness rates were often low. For the modern aviation enthusiast, the MiG-27 offers a masterclass in the trade-offs of aircraft design. It teaches us that a bigger gun is not always better if it damages the mount. It teaches us that variable geometry wings are a heavy solution to clarity, a specific aerodynamic problem. It teaches us that multi-role is a modern luxury. In the Cold War, you were either a fighter or a striker, and trying to convert one to the other was a messy, compromised process. The MiG-27 was the ultimate conversion, a high-altitude interceptor forced into the mud to brawl with unmatched ferocity. It was never the perfect aircraft. It was never the most elegant. But for a period of 20 years, it was one of the most feared silhouettes on the other side of the Iron Curtain. If you found this analysis useful and want to see more deep dives into the forgotten beasts of the Cold War, a like helps more people discover this content. Thanks for watching.